Try to imagine a heat that the human brain simply refuses to comprehend. 1,000,000 degrees. This isn't just hot, it is a state of matter where atoms go mad, where electrons are ripped from their orbits, turning everything into a seething, boiling soup of plasma. This is the sun's corona, the most hostile environment in our star system. And right now, at this very second, a mountain of ice is hurtling through this hell. It is moving at a speed that would make any earthly pilot black out instantly, hundreds of miles per second. This isn't just a flight, it's a fall, an endless, fatal fall into the abyss of gravity. We call this object Comet C2024 S1 Atlas, but journalists have already christened it the Halloween Head. A catchy headline, isn't it? It sells fear perfectly. It promises mystery. It hints that on October 31st, the day we pretend to scare each other with made-up monsters, the sky is going to show us a real one. But the truth buried in the dry reports of astrophysicists is far more terrifying than any ghost story. The truth is, the universe doesn't care about our holidays. It doesn't care about our fears. Up there, a giant, ruthless mechanism of celestial mechanics is grinding away, and right now, it is crushing the bones of yet another cosmic wanderer. Welcome to our investigation. Today, we aren't reading tea leaves. We are reading the Celestial Autopsy Report. You've probably seen the news. Social media feeds are blowing up. They tell you it's a sign. They tell you that a comet flying toward the sun on the eve of All Hallows Eve is a harbinger of doom. Some are screaming about the end of the world. Others are packing go bags for their bunkers, waiting for an asteroid impact. And the more reserved among us simply feel a vague sense of anxiety. And that is normal. We humans are genetically hardwired to fear these hairy stars. It's programmed into our subconscious. Think back to 44 BC, Rome, the assassination of Julius Caesar. A comet flares in the sky, and the Romans, a rational, brutal people, suddenly lose their composure. They see the dictator's soul. They see a death sentence for their republic. Flash forward to 1066. England, the Battle of Hastings. Halley's Comet hangs over the battlefield. For the Anglo-Saxons, it was an omen of defeat. For the Normans, a sign of victory. Same physics, completely different interpretations. We don't look at the sky with our eyes. We look with our fears. And today, in 2025, when the world is already cracking at the seams from wars and crises, the appearance of a bright comet acts like a match thrown into a barrel of gunpowder. But let's put emotions aside and turn on cold logic. What exactly is coming at us? Why did astronomers get so tense when the Atlas system, the Asteroid Terrestrial Impact Last Alert System, flagged this blip on their monitors? It's not because it might hit Earth. Spoiler alert, it won't. The issue is that this comet is a member of an elite suicide club known as the Kreutz Sungrazers. Remember that name, Heinrich Kreutz. The man who realized comets can have a pedigree. Picture a colossal block of ice, the size of a major city, invading the solar system thousands of years ago. It was magnificent and massive, but the sun is a strict landlord. It doesn't tolerate trespassers. Gravity tore that progenitor apart, and now, centuries later, these shards are returning. They are traveling on the exact same track, like trains on a rail, one after another, to finish what their father started, to die in fire. Comet Atlas is not a solo player. It is debris from an ancient catastrophe, and its trajectory is a kamikaze run. Perihelion, the closest point to the sun, is just 1.2 million kilometers, or about 750,000 miles from the star's center. Sound like a lot? In space, that is nothing. That is point-blank range. It's barely a scratch on the photosphere. Given the sun's radius, the comet will fly just 300,000 miles above the boiling surface. Imagine flying a plane 30 feet above the mouth of an active volcano. Now multiply the heat by 1,000 and the radiation by 1,000,000. That is where our icy guest is headed. And this is where the real drama begins. The drama of physics. Why is the internet buzzing? Why are conspiracy theorists drawing maps of the apocalypse? Because this object isn't behaving the way the average person expects. We are used to comets being these beautiful little balls with tails that hang in the sky for months, like Hale-Bopp in '97. Remember that? It was visible for a year and a half. But Kreutz comets are different beasts. They are fast, they are bright, and they are unpredictable. The web is full of rumors. It'll flip the sun's magnetic field. It'll trigger a superflare that fries electronics on Earth. People feel a threat they can't articulate. They fear the unknown. And this fear is fueled by the fact that the comet is acting strangely. Even on the approach, long before the danger zone, it started blinking. Its brightness chart, which should have been a perfect upward curve, suddenly crashed. It's like the EKG of a patient going into arrhythmia. The comet's heart lost its rhythm. What does this mean? It means processes have begun inside the icy core that we can't see yet, but we can calculate. Thermodynamic shock. Imagine a chunk of ice thrown into a blast furnace. It doesn't just melt, it explodes. Gases inside the core expand with such force that they tear the rock apart. But there is a force scarier than heat, tidal forces. The sun's gravity pulls the nose of the comet harder than the tail, stretching it like a rubber band, trying to turn a sphere into a string. And this cosmic tug-of-war is being fought by two fundamental forces: the gravity holding the comet together and the tidal forces of the star trying to destroy it. Who wins? We are standing on the threshold of a once-in-a-decade event. Either we see the greatest show of our lives, a great comet, visible in broad daylight, brighter than the full moon, with a tail slicing across half the sky, or we see the greatest disappointment, a fizzle, a cloud of dust vanishing without a trace. The bets are placed, the roulette wheel is spinning, the ball is rolling along the rim, and that ball is made of dirty ice. Why the Halloween head? Because quite possibly on that very day, the comet will lose its head. Literally, the core could disintegrate, leaving behind only a ghostly trail, a headless tail drifting in the vacuum. Symbolic, isn't it? But don't relax just yet. Even if it breaks apart, the energy doesn't disappear. The mass doesn't disappear. We are talking about thousands of tons of matter slamming into the star's atmosphere at hypersonic speeds. It is a collision, an impact. And although the sun is a giant, even a mosquito bite can cause irritation. And this mosquito is moving very fast. We have to ask ourselves, are we ready for what we're about to see? Our telescopes, our satellites, our eyes are locked on one point in the constellation of Virgo. We are waiting for the climax. And here, I want to pause and address the skeptics. Those who say, here we go again, fear-mongering, nothing's going to happen. In science, a lack of result is still a result. But in this case, nothing is not an option. Something will happen. The question is only the scenario. Will it be the Ikea-Seki scenario of 1965, when the comet survived and terrified half the world? Or the Lovejoy scenario of 2011, when it emerged from the fire like a phoenix, only to burn out later? Or perhaps we face the Ison scenario, where the comet simply evaporated, becoming a ghost on live TV. Each of these options is a physics lesson taught to us by the universe. A brutal visual lesson, and we are sitting in the front row. So, what is Comet Atlas? A messenger of the gods? A harbinger of war? Or just a dirty snowball with bad luck? The answer lies not in mysticism, but in hard, cold mathematical calculation. And we are going to run that calculation right now. We're coming down from the clouds to the ground, or rather rising from emotions to facts, because fear is just a deficit of information. My job is to give you that information, full volume, uncensored, unvarnished. Get ready. We are diving into the anatomy of a cosmic catastrophe. To understand the nature of what we faced in the fall of 2024, looking at telemetry isn't enough. We need a deep reconstruction. We are moving to a detailed analysis of the dossier on Object C2024 S1 Atlas. This isn't just an isolated rock that stumbled into our neighborhood. It is a fragment of a grand cosmic puzzle that astronomers have been piecing together for over a century and a half. The story begins not in the 21st century, but in the 19th. German astronomer Heinrich Kreutz, working at Kiel University, noticed a strange statistical anomaly. Studying the orbits of several bright comets from the past, he found their trajectories were practically identical. They came from the same direction, passed extremely close to the sun, and left toward the same region of space. Kreutz proposed a hypothesis that became the foundation of modern cometary astronomy. All these objects are shards of one giant progenitor. Mathematical models allow us to rewind time. Calculations show that the Kreutz progenitor was a true icy leviathan. Its diameter, by various estimates, could have reached 60 or even 120 miles. For comparison, the famous Halley's Comet has a core only about 7 miles wide. This was a giant that invaded the inner solar system thousands of years ago. Most likely, the first catastrophic breakup happened in the 4th century BC. Ancient sources, including Aristotle, mention a blindingly bright comet that split in two before the eyes of observers. That was the birth of the Kreutz family. Since then, this swarm of debris has continued to travel through the solar system. Their orbit is a wildly stretched ellipse. The aphelion, the farthest point, lies far beyond Neptune in the cold Kuiper belt, or even the Oort cloud. There, in absolute zero, the comets spend centuries moving slowly. But the moment gravity starts pulling them back to the center, they accelerate, turning into kinetic projectiles. The orbital period varies from 500 to 800 years. That means Comet Atlas was likely last in our neighborhood during the Middle Ages, back when it was still part of a larger chunk. Now let's look at the mechanics. What makes Kreutz comets physically unique? The key parameter is the perihelion distance. Comet S1 Atlas passed at a distance of just 0.008 astronomical units from the Sun's center. In plain English, it flew through the star's outer atmosphere. In this zone, the laws of magnetohydrodynamics and plasma physics turn a simple flight into a stress test for materials. The internal structure of a comet isn't solid rock. The standard model describes it as a dirty snowball. It's a conglomerate of water ice, frozen carbon dioxide, methane, ammonia, and silicate dust. This structure is porous and extremely fragile. The density is often less than water. When an object like this approaches the sun, sublimation begins. The ice doesn't melt into water. Liquids can't exist in a vacuum. It flashes instantly into gas. Imagine the pressure building inside a porous body when volatile substances start vaporizing throughout its entire volume. It's like millions of microscopic explosions. The gas forces its way out, bursting through cracks and cavities, dragging dust with it. That dust reflects sunlight, creating the visible coma and tail. But Kreutz comets have another enemy: solar radiation. At perihelion, the energy flow from the sun is thousands of times stronger than what we get on Earth. The surface temperature can spike to thousands of degrees, while the inside remains deep frozen. This temperature gradient creates monstrous mechanical stress. The comet is literally being torn apart from the inside by thermal shock. But the most destructive factor remains tidal forces. According to the Roche limit, every celestial body has a critical distance from a massive object where gravity rips the satellite apart. The sun is a gravitational monster. On approach, the pull on the comet's nose is significantly stronger than the pull on its tail. The core is stretched along the line of flight. If the comet's internal gravity and cohesion are weaker than that difference, the inevitable happens. The core crumbles like a sandcastle hit by a wave. History gives us plenty of case studies. We can predict Atlas's fate by looking at its sisters. Take the Great Comet of 1882. It passed perihelion, literally piercing the solar corona. Observers saw it with the naked eye right next to the sun. It survived, but paid a high price. Its core shattered into 4 or 5 large fragments that continued flying like a string of pearls. This proved that a large enough, dense enough body can survive a meeting with the sun, albeit at the cost of structural integrity. A more recent example, Comet Lovejoy 2011, a medium-sized comet, also a Kreutz sun grazer. Astronomers watched via space telescopes as it dove behind the solar disk. Experts were sure it would evaporate, but to everyone's amazement, it popped out the other side. It lost its tail, its coma was stripped by solar wind, but the core survived, at least for a few days. After perihelion, it crumbled into dust. These precedents give us the keys to understanding S1 Atlas. Unlike the comet of 82, Atlas was smaller. Unlike Lovejoy, it showed signs of instability much earlier. Spectral analysis showed expulsions of not just dust, but atomic gas, evidence of deep structural failure. We weren't watching a solid rock. We were watching a dense swarm of debris held together by nothing but inertia and weak gravity. So, our investigation moves from observing a dot in the sky to understanding physical inevitability. Comet S1 didn't have the mass to resist tidal forces, nor the structural strength to withstand the thermal shock. Its fate was sealed by the laws of physics the moment it crossed Mars's orbit, and began accelerating toward its fiery finale. This wasn't an accident. It was a strict pattern running like clockwork in the solar system. At this stage, we move from analyzing evidence to delivering the verdict. We've gathered the data on origin, physics, and history. Now it's time to compare the public hype with the harsh reality of telemetry. This is the moment of truth, where myths shatter against graphs and fears give way to thermodynamics. We are entering the trial of Comet Atlas. The public outcry was built on the expectation of a grand show. Media painted pictures of a flaming sword in the sky, or a sinister green skull looming over Earth for Halloween. These expectations were extrapolations of early data, back when the comet was far from the sun and highly active. But science doesn't tolerate linear extrapolations in non-linear systems. Reality started drifting away from the forecast in early October. The key witness for the prosecution against the Great Comet theory was the light curve. In a standard model, brightness should increase as the distance to the sun decreases to the fourth power. But Atlas broke that law. Instead of an explosive growth in brightness, astronomers recorded stagnation and then a drop. This wasn't just a glitch. It was a distress signal. The core, that loose clump of ice and dust, ceased to exist as a single physical body long before perihelion. What we watched in the final weeks was no longer a comet, but a stretched cloud of debris, agonizing under the streams of solar wind. Here is the plot twist. The turn that makes this situation truly dramatic from a scientific perspective. We were afraid of the wrong thing. Society worried about the comet's impact on Earth, about mystical omens. But the real drama was happening in a completely different dimension. This wasn't a story about a threat, it was a story about vulnerability. We witnessed how a massive mountain of matter turns into nothing in a matter of hours. The real intrigue wasn't what the comet would do to us, but what the sun would do to the comet. October 28, 2024. The event horizon. The comet, or what was left of it, entered the field of view of the Soho Observatory's coronagraphs. These instruments, LASCO C2 and C3, are our eyes, staring directly into the face of the star. Astronomers worldwide waited for a bright bolide to streak across the corona, but the screens showed something else. At the calculated time, only a pale, blurry smear appeared, lacking a solid center. It was the comet's ghost. The physics of this moment is called full sublimation. The remnants of icy matter hitting temperatures over 1,000,000 degrees didn't just evaporate, they ionized. Atoms lost their electrons, turning into plasma. The dust component couldn't withstand the light pressure. Solar radiation this close to the photosphere acts like a massive press. It literally blew the dust tail away, scattering it into space. Comet Atlas was annihilated. It ceased to exist as an astronomical object. This event was a vivid demonstration of our star's power. The energy released by the comet's destruction was colossal by human standards, equivalent to a nuclear arsenal detonating. But against the background of the sun's own output, it was less than a raindrop falling into the ocean during a hurricane. The sun didn't even notice the invasion. No flares, no coronal mass ejections triggered by the impact. The scales of mass are simply incomparable, so the climax of our investigation leads to a paradoxical conclusion. The scariest event predicted by the headlines turned out to be the most invisible event of the year. The Halloween head lost its head, body, and tail, dissolving into the solar wind. We didn't see a celestial show, but we got something more valuable: confirmation of our models. We saw the limits of material durability. We saw the solar system's cleaning mechanism in action. And most importantly, we proved that our observation tools can track the death of the invisible. Now, as the courtroom empties and the verdict of death by natural causes is read, we only have to process the consequences. What does this mean for future observations? What lessons should we learn from this cosmic execution? And finally, when can we expect the next visitor from the Oort cloud? Concluding our analysis of Comet Atlas, we move from the fact of its death to the implications. In science, the disappearance of an object doesn't mean the disappearance of information. On the contrary, the destruction of a celestial body this close to the sun provided astrophysicists with a unique dataset that will take months, maybe years, to decode. The first and most obvious result is the verification of our prediction models. The Atlas system proved its worth not just as an asteroid warning tool, but as a monitor for dynamic processes in the inner solar system. The fact that we caught the object early, calculated its orbit, and predicted the time and place of perihelion with high precision proves the maturity of modern celestial mechanics. However, the discrepancy in brightness predictions shows that our models of internal comet structure still need work. The case of Comet S1 will become a textbook example for calibrating future sublimation calculations. The second aspect concerns the future of the Kreutz family. We must understand, the Comet of 2024 isn't the series finale, it's just another episode. The Kreutz conveyor belt keeps running. Orbital dynamics indicate that thousands of fragments are sitting in the Kuiper belt and Oort cloud, slowly but surely moving toward their fatal date with the Sun. Statistics tell us that small fragments appear every few years, and large ones every few decades. The scientific community looks to the future with cautious optimism. Sooner or later, gravity will send us a fragment comparable to the Great Comet of 1882. It is inevitable, and when it happens, we will be ready. Modern solar observatories like the Parker Solar Probe and Solar Orbiter will allow us to study this process in unprecedented detail, literally diving into the comet's atmosphere as it passes through the corona. We aren't just expecting a pretty sight. We expect fundamental data on the protomatter that formed our planetary system 4.5 billion years ago. Now, let's do what drone operators call a zoom out. Change the scale. Step back from the specific block of ice and look at the global picture. Why did the story of Comet Atlas resonate so much, despite having zero physical effect on Earth? The answer lies in anthropology and psychology. Humanity seeks patterns and signs. The coincidence of perihelion with Halloween was pure chance, a statistical fluctuation. But for the observer on Earth, it became a narrative. We named it the Halloween head, we gave it the properties of a messenger, we projected our collective anxieties onto it. However, the universe, as this case shows, is absolutely indifferent to our calendars and holidays. The processes of birth and death of matter happen continuously, obeying only the laws of thermodynamics and gravity. The comet didn't burn up because it was a sign, or because the stars willed it. It burned up because its internal binding energy was less than the external energy acting upon it. It is a cold, sobering, but in its own way, majestic lesson. We are observers in a giant laboratory, and our job is not to fear the flashes in the test tubes, but to understand the nature of the chemical reactions. The bottom line is, the event of autumn 2024 can be classified as a successful live fire experiment in plasma physics and cometary astronomy. We didn't get a great comet visible at noon, but we got confirmation that space is a dynamic, aggressive environment where stability is the exception, not the rule. Comet Atlas completed its mission. It died so we could get a little smarter. As a postscript and a recommendation for those who want to dig deeper, don't stop at reading headlines. Open the Soho Mission Archives. Watch the time lapses showing dozens, hundreds of small comets diving into the sun every year, like moths into a bonfire. This spectacle has the hypnotic power of reality. It reminds us of our place in the universe, a small place, but a privileged one because we are the only ones capable of comprehending the beauty of this mechanics. Watch the orbits, check the facts, and keep your critical thinking sharp. Stay tuned on the Frequency of Science.